Hi, and welcome to Synapse. In today's episode, let's talk about the hormone synthesis in the adrenal cortex. Okay. This is a pretty important topic so as to understand endocrinology, the medicine part of it, and very importantly, the pediatrics part of endocrinology. So, let us talk about the adrenal cortex. Okay, so adrenal cortex develops from the neuroectoderm. Okay, so if I'm trying to draw the adrenal cortex here, a triangular shaped gland. So this is the cortex, this is the medulla. So medulla develops from the mesenchyme, mesodermal origin. So this is to be remembered. They are coming from different sources. So one is from the ectoderm, the other one, the medulla, is from the mesoderm or the mesenchyme. Fine. So now the cortex itself has three layers. Okay, so we have studied this in histology. So it is GFR. So the mnemonic is GFR. So G stands for zona glomerulosa. F stands for zona fasciculata. And R stands for zona reticularis. Okay, simple. GFR. Now, what we need to remember is what does this corresponding layers produce? So they produce hormones, right? So the adrenal cortex hormones. So glomerulosa produces mineralocorticoids. Fasciculata produces glucocorticoids. And reticularis produces sex hormones. Okay, simple. Mineralocorticoids, glucocorticoids, and sex hormones. So now today we are going to deal with the production of these hormones, okay, and how it happens. Okay. Fine. So now starting off, okay, the synthesis, biosynthesis of adrenal hormones. Okay. This topic is very important because you're going to encounter this in physiology, you're going to see this in medicine, you're going to see this in pediatrics, and there are a lot of applied aspects of the biosynthesis. This table might seem a little difficult. Let's make it simple, but once you learn it, you can answer any question, okay, based on the pathway. Okay, so it's pretty complicated. Let's make it simple. Okay, so first, the raw material for all of this, okay, the raw material is cholesterol. Okay, very important. Now the adrenal gland is going to basically harvest the cholesterol from the circulation. So this synthesis process, okay, takes place in the mitochondria of the adrenal cortex. So if this is the mitochondria, okay, so the cholesterol has to be taken from outside to inside. So there's a channel here. Okay, there is a protein there. It's called a star protein. Okay, that protein is responsible, or that is essential for the uptake of the cholesterol from outside to the inside of the mitochondria. So this is very important. It's a rate limiting step here. It's a rate limiting step. Okay, and this is under the influence of ACTH. Okay, adrenocorticotropic hormone. Correct? So simple. First step, cholesterol goes inside. That's it. Next, what happens to this cholesterol which has gone inside? Fine. You know what? We'll just take up a different slide and let's put that here because it's extremely important, right? So it's nice if you can go ahead with me, like right along with me. You have cholesterol. Okay, so once it has come inside, it is going to get converted into what is called as pregnenolone. Okay, this becomes 17 hydroxy pregnenolone. Okay, then this becomes DHEA, dihydroepiandrosterone. Okay, fine. So it is pregnenolone, 17-hydroxypregnenolone, and DHEA. Now this is the backbone. Okay. Now let us see how this basically, now we're going to see the horizontal part of the table. Okay. So pregnenolone will get converted into progesterone. Okay. So similarly, this will get converted into 17-hydroxyprogesterone. Simple. Okay. Now this progesterone is further going to get converted into deoxycorticosterone. Okay. And this is going to convert it into deoxycortisol. Okay. So now we'll get rid of the deoxy part. Okay. So we will just be left with cortisone. So here also we'll have cortisol. So this will get further converted into aldosterone, okay, which is your mineralocorticoid. Cortisol will get converted into cortisone, which is your glucocorticoid. Okay. Okay. So they're pretty similar. So you can write it off at once. Next, if you look at DHEA, this is a little different. It becomes androstenedione. Then it converts into testosterone. Then this becomes dihydrotestosterone. Okay. So this is the vertical part of the table. Okay, the biosynthesis. This is the horizontal part of it. Okay. Now our job is to put on the hormones here. Okay, we just need to drop in the hormones. So now pregnenolone to 17-hydroxypregnenolone. So of course the enzyme here should be 17-alpha hydroxylase. Okay, 17-alpha hydroxylase, and here also similar enzyme is required, 17-alpha hydroxylase. Okay, simple. So the vertical part of it will have 17-alpha hydroxylase. Now we'll take up a different color and we'll put in the enzymes here, the horizontal part of it. So first here remember three numbers, 3, 21 and 11. Okay, I'll make that pretty clear later on. So this is 3-beta hydroxy steroid dehydrogenase. Okay, so yeah, it seems a little complicated, but let's make this simple in a while. So then 21 hydroxylase, 11 beta hydroxylase. Fine. So this, the mineralocorticoid activity here. Okay, this is mineralocorticoid, this is glucocorticoid pathway. So these are very similar. So I'm going to put in the same hormones. This is 3, 21, 11. Okay, beta hydroxy hydrogenase, dehydrogenase. Okay, yeah, it looks a little shabby, but it's the same enzyme. Okay, so here also 21 hydroxylase and 11 beta hydroxylase. Okay, now further on, and here, okay, so this enzyme is what is important for us. Okay, we'll deal about it, we'll talk about it later on. So now this pathway, will come to this in a while. Now how do we remember these numbers? Okay, okay, 3, okay, can be as well written as 2 plus 1. Okay, so we are writing 21 here, and then subtract 1 plus 2, 1 from 2, so it will be 11. Okay, that's how I try to remember it. So it is 3, which can be written as 2 plus 1. Okay, so 2 minus 1 is 1, so you'll get 11. So this is the order. Okay, so if you can go back here and check our table, it is 3. Okay, so it is 3, 21 and 11. So the vertical part of it, this branch, okay, it is 17. Okay, it is pretty simple to remember. Okay, now it makes sense, right? So just try to write this thing on your own. Okay, once you understand it, take a piece of paper, just write it down. Okay, but the logic to be remembered is 3 is 2 plus 1, then becomes 11. Okay, the vertical part is 17. Now, what is the importance? Why are we studying this in great detail? Why should we know each and every number and enzyme and so on? Because there's one condition called congenital adrenal hyperplasia. Congenital adrenal hyperplasia. So what happens in this is there is deficiency of one or the other enzyme that is involved in this pathway. Okay, so as a result of which we'll have certain clinical features. Okay, to reason that out, we need the flow chart, correct? The synthesis pathway. Now for this one, okay, congenital adrenal hyperplasia, there could be absence of either 21 hydroxylase or 11 beta hydroxylase or 17 alpha hydroxylase or 3 beta hydroxysteroid dehydrogenase, correct? So any of the 4 enzymes could be absent, then all of it will lead to CAH. So different varieties of that. So write the numbers in the descending order. Okay, so 21 comes first, and then we have a 17, then we have 11, then we have 3, correct? And now we have to do a little bit of switching. So bring 11 here and 17 there. So it becomes 21, 11, 17 and 3. So 21 hydroxylase deficiency is the first, that's the most common variety of CAH. And the second most common enzyme that is deficient is 11 beta hydroxylase, then is 17 and then is 3. Okay, so that is how you remember the order in which the deficiency of the enzymes will occur in CAH. Okay, so now here let's take up a clinical scenario. Let's say there's a child. Okay, there's a child where you have this enzyme deficiency, that is 21 hydroxylase deficiency has happened. Okay, so now what will you do? Okay, what will be the clinical features? Let's first see the clinical features. So I am just writing here pregnenolone, the flow chart in like short forms. Okay, so it's lead to progesterone, then this is going to become dihydroxycorticosterone becomes aldosterone. Okay, basically here one more step, corticosterone then becomes aldosterone. This becomes 17 hydroxy pregnenolone, 17 hydroxy progesterone, then becomes dihydroxycortisone, then cortisol. Sorry, this is cortisol. Then cortisol will lead to cortisone. Okay, so basically it's the same chart. I'm just writing it again. And DHEA, and then which will ultimately lead to your testosterone. Okay, so every time this question comes, either if you can imagine this, if you can put up this, bring this image in your mind, well and good. Otherwise, just write it down. Just the short forms like this. Okay. Now now what we'll do is we'll put on the enzymes here. So this was 17 alpha, 17 alpha. I'm just putting the numbers here. So we know it is 3, 21, 11, 3, 21, and 11. And here also we need 3. Okay, that I didn't mention in like previously. It is just 3 here. So it is the 3 beta hydroxylase. That's the enzyme. Now, the scenario here is 21 hydroxylase. This enzyme is deficient. Okay, so this part of it is not happening, so this cannot proceed further. Okay, so till here you can form progesterone. You can form 17 hydroxyprogesterone. Correct. So as a result, what happens when the horizontal thingy, the pathway is blocked? So more of the enzyme will go into the vertical pathway. So you have increased amounts of DHA production. Okay, so let us write a clinical feature here. Let's use black. Okay. First of all, what is happening to mineralocorticoid? Your aldosterone is less, so mineralocorticoid deficiency is happening. Correct. Next, are you producing your cortisol or cortisone? No. So the next is glucocorticoid deficiency. Okay. Next, what will happen? Look at this pathway. DHEA is excess. Excess DHEA which will lead to increased testosterone and increased dihydrotestosterone. Now, what is the implication of this? Increased testosterone. Okay, so what happens in boys and what happens in girls? In boys, it will lead to precocious puberty. So basically increase in the male hormones. Okay, it will lead to early onset of puberty before 9 years in boys, less than 9 years in boys. In girls, what happens during the development of the fetus? Okay, the absence of testosterone in a female fetus will lead to the development of the female external genitalia. Okay, let me repeat it again. Okay, or I'll just make let's use another slide here. Okay, so basically if there is testosterone at the development of the fetus, okay, if it is present, then the external genitalia would be male. Okay, if there is absence of testosterone, it will become female external genitalia. Very simple. Okay, this logic is to be remembered. Now let's come back here. Okay, what is happening here in girls? Okay, girls, so they have, it is XX. Okay, she has ovaries and uterus and everything. Okay, but the external genitalia, because of the presence of testosterone, would look like male. Okay, so there is ambiguous genitalia. So what are the features of ambiguous genitalia here? They will have in a female, okay, if there is ambiguous genitalia in a female, it is called as female pseudohermaphroditism. Okay, as in inside, okay, the internal reproductive organs are normal. They're that of female, that is ovaries are present. Okay, so hermaphroditism is basically the fusion. Okay, it is like instead of having the labia and basically the external genitalia of a female, they'll have features of both mixed male and female. So they'll have clitoromegaly. Okay, then fused labia. Okay, so and there will be fusion of urogenital sinus. So these are all features, okay, of basically it is features in between male and female, correct? So this is all because of excess testosterone or androgen during development. Okay, in the female fetus. Okay, that is ambiguous genitalia in a female fetus. Okay, fine. Now here, this is what we have finished, right? So we have discussed there is no mineralocorticoid, there is no glucocorticoid, and DHEA excess in boys causes precocious puberty, in girls it causes ambiguous genitalia. Now how are we going to treat this condition? Since we discussed 21 hydroxy deficiency, because it is the most common enzyme that is missing, okay, that is responsible for CAH. Okay, so how do you treat this? We need to supplement mineralocorticoid from outside. Okay, we can give fludrocortisone, then we can give hydroxycortisone, basically for the glucocorticoid supplementation from outside. And boys is pretty much like nothing you can do. It's precocious puberty, it's fine, it's just excess testosterone in boys. In girls, what happens? The ovaries are present, uterus is present, okay, there should be no problem with fertility. So what you do is you just do a reconstructive surgery. Okay, so you do a surgery here, and then you're going to construct the vagina and so on, so that the sexual intercourse is possible and she can conceive. Okay, that is how we manage this condition. So why is it called congenital adrenal hyperplasia? Now we have just studied in this 21 hydroxylase deficiency, we don't have glucocorticoid, correct? We don't have glucocorticoid. So that is your cortisone. So this cortisone has a negative feedback, okay, on the production of ACTH from the pituitary, correct? Now here we are not having corticosterone, okay, sorry, cortisone. We're not having that. Basically your glucocorticoids are not there. So this negative feedback is not there, correct? So the pituitary thinks it does not sense any cortisol. So there'll be overactivity of the pituitary and you'll have increased production of ACTH because of this. Now, we have studied what are the layers of the cortex: adrenal cortex, G, F, R, granulosa, fasciculata, and reticularis. Out of these, okay, it is the fasciculata and the reticularis which are under the uh, effect of ACTH. Basically, ACTH will stimulate these two layers. Okay, so when there is increased ACTH, trophic hormones, correct? So it is going to stimulate these two layers. There will be excessive proliferation of these two layers. So the adrenal gland, this is a normal size, because of this excess ACTH, the gland will become like this. There will be hyperplasia. That is why it is called congenital adrenal hyperplasia. Simple. Okay. So the hormones that are absent, sorry, the enzymes that are absent here will be 21, followed by 11, followed by 17, followed by 3. This is pretty rare. Okay, and others we can just work it out here. Okay, let us just have a look at this. We can work it out here. If um, 21 is absent, we have just told what happened. If 11 is absent, okay, again you will not have corticosteroid, but deoxycorticosterone will have some amount of mineralocorticoid activity. Similarly, deoxycortisol will have some glucocorticoid activity. So 11 beta hydroxylase will not present early. Okay, so there will be some amount of mineralocorticoid and glucocorticoid activity. Okay, but what happens in 11 beta hydroxylase deficiency is the excess activity of deoxycorticosterone will lead to hypertension. Too much of retention, okay, salt water retention, it will lead to hypertension. That is one thing to be remembered. And if we talk about 17 alpha hydroxy deficiency, okay, so basically your pregnenolone will increase. Okay, the horizontal pathway will go on. Your mineralocorticoid excess will be there, while you don't have glucocorticoid, and you will not even have the sex hormones. Okay, may it be male or female. Okay, it is not there. Correct. In female, if there is no testosterone, no problem. In a male, what happens? It will lead to ambiguous genitalia in male. So basically, 17 alpha deficiency, there will be ambiguous genitalia in male, and they'll have glucocorticoid deficiency, while their mineralocorticoid activity is normal. Okay, and then lastly, we spoke about 3 beta hydroxy deficiency. Okay, this one, when this enzyme is deficient, so your side chain is not, this part of the reaction is not happening, it's not progressing in this way. So you'll have both mineralocorticoid deficiency and glucocorticoid deficiency, which is similar to what we discussed, that is 21 hydroxylase deficiency. But your DHEA, okay, again, see, for this conversion, again here I said you need beta 3 beta hydroxy, basically hydroxylase. This deficiency will occur, right? So none of the horizontal chains will progress, so you will not have testosterone. So what happens in that condition? No testosterone, so the males will have ambiguous genitalia, and excess of DHEA in a female, again it will cause ambiguous genitalia. So in 3 beta hydroxylase deficiency, you have ambiguous genitalia in both males and females. Okay, so I guess I have made this clear. So if at all, okay, anything to do with adrenal cortex hormones, first you need to just put this chart in your mind. Okay, it is basic, it's just like mathematics. Okay, you, if that particular or the enzyme is missing, so what will happen? Okay, it is very logical, you can come up with your own, outcomes. You needn't really mug it up. Okay, so I hope this video helped. Okay, and yeah, thank you. Subscribe and like the video. Thank you.